Alright, here is the video guide for lesson 2.1.4, focusing on the angles in a triangle. So we've talked about when angles intersect, or when lines intersect, excuse me, and you end up getting a vertical angle relationship just by having two lines intersect. We've also talked about relationships created when transversals intersect two parallel lines. That is our corresponding angles, our alternate interior angles, and our same side interior angles. Today we're going to focus on these three non-parallel lines intersecting or just having a triangle form. Okay? This problem here is very long, but to keep it short and sweet, what we're going to be doing is coloring angles in the triangles. Okay? So like if this here is my blue angle, I color it blue, and then every other angle that's the same as this one needs to be colored blue in my diagram here. So here are my blue angles. Okay? Once I have blue ones done, every angle in here is different, so you got to change colors. Down here maybe is my red angle, and so everything that shares that are my red angles. Okay, something like right here as well, and right here. Now again, this is a scalene triangle, and all three are different, so we got to change colors one last time. And now these last ones are going to be my green. Okay, and what we're trying to do here, what we're trying to see is, well, my triangle is made up of blue, red, and green, but look what's happening when those angles come together. Red, blue, green, they're creating a straight line, which makes me start to think, well, maybe these three angles in a triangle add up to be 180 degrees. And so I write, if a polygon is a triangle, then the measure of its angles I believe to be 180. Next, we can go into actually investigating it a little bit further. And we can take a look here. If you look to the left, it says the sum of the angles equals 180, and that's good. But what happens is I start moving things around. Well, I can see A and B and C are changing, but the sum is always 180. No matter what point I move, no matter what I'm doing here, it always equals 180. And so that kind of confirms what I'm seeing in that first part, being like, okay, I thought that was the case, but now it looks to really be the case. So I move on and I kind of go off that assumption, or actually almost a proof there. All right, and I say, well, what is x if there's 40, there's 80, I need to get to 180? What is x going to be? Okay, or another way you can think about it is x plus 80 plus 40 needs to equal 180. So I'll even write it out here: x plus 80 plus 40 equals 180. And we can do some algebra to solve for x. Okay? The reason I like to write it out like that is there's a problem right here where you have now x's in here. And so if you add up all three angles, set it equal to 180, solve for x, you can figure out these missing angles. Okay? This is a more challenging one. If you want to see this one as an individualized video, just let me know. Here, we know that this is an equilateral triangle, meaning all three angles are the same. And so we got to say, well, all three angles added together need to equal 180, and all three angles need to be the same. So what must they be? Here we have 190, and then two angles here that must be the same, because this is an isosceles triangle, isosceles right. So this angle and this angle have to be the same. We know 90 of the degrees are already taken up here, so you have 90 degrees left to fit into these two angles, and you can try to figure out what that would be. Here, we know that A is 34, so this angle up here is 34, and we know that B and C are going to be the same because, again, it's isosceles. So you have 34 taken away, which leaves you with so many degrees left to work with. And so you got to say, I have this many degrees left, half of it has to go to B, half of it has to go to C. We got to figure out what that number is. And then lastly, my favorite problem on here is you got to try to figure out every missing variable using the relationships we've talked about the past week, starting last week. Okay, so 57 and K, that's a vertical angle, so maybe you say K is 57, right? 57 and M, that relationship is supplementary, so you can find M, okay? And you work around and you're able to find every variable in here. There's a lot going on, there's a lot of things, a lot of pieces moving here. If you like to see me solve a couple of them, just let me know, okay? That's it. We have a kind of a knowledge, not check, but how do we feel about the lesson at the end? Don't forget about that. And again, as always, if you want to see something or if you have questions, feel free to email, and I'm happy to make videos.